So this is our second example on functions, on limits of functions of the type sin ax over ax. And what makes this one a little bit less obvious is that you have a sine function on the top and bottom of the fraction, and you don't have any function in x at all. But we can still use the same technique that we've had to figure out how to do this problem. So we begin by writing out the problem as it is. We've got the limit as x approaches 0 of sine of 5x over sine of 3x. Now we have sine of 5x on top, and we know from the last example and from this whole idea that to get sine of 5x into a form that we want, then we need 5x on the bottom as well. So let's multiply the bottom of this by 5x. Just as we had the last time, if we're going to multiply the bottom of a fraction by any term, any expression, then we also have to multiply the top of the fraction by the same expression, just to keep it in balance. So to make sure we're really actually multiplying by 1, we're going to multiply the top by 5x as well. So if we multiply by 5x on the bottom because of the sine 5x on top, and then we have to balance it out, so we multiply by the other 5x as well. We have a sine 3x on the bottom of the original expression. To get the sine of 3x to go away, we need a 3x on top. So we're going to multiply the top of this expression by 3x. Again, for balance, make sure we're multiplying only by 1, we need to multiply the bottom of the expression by 3x. The rest of this problem is going to be taken up with just rearranging terms. Now, we're going to start off again, the limit as x approaches 0. Let's start off with the sine of 5x. Okay, because we had sine of 5x. Now we're going to move things around. Nothing's going to change, but we're going to move things around. To get this sine of 5x to go away, we need a 5x on the bottom. So let's say that now this 5x that we've just used came from here. Okay? So we've used that 5x. We're also going to need to deal with the sine of 3x on the bottom. Okay? And to deal with that, we need a 3x on top. So the 3x on top came from this 3x here. That's that one. Okay, so we've used the 5x on the bottom and we've used the 3x on top. We've also used the two sine functions, and now we have to remember to deal with the two pieces that we haven't used yet. That's this piece and this piece. So it's going to be 5x and 3x. Those are the bits that we haven't used yet. Okay, well, one of the things you can do with limits is when you're getting the product, the limit of a product like this, we can simply get the limit of each part of that separately. So it becomes the limit as x approaches 0 of sine of 5x over 5x multiplied by the limit as x approaches 0 of 3x over sine of 3x multiplied by the limit as x approaches 0 of the piece on the end, 5x over 3x. Okay, well, if you look at the first two, this one and this one, they match the criteria that we set up earlier. The limit in both cases, x is approaching 0. Again, sine of 5x over 5x, the argument is the same. The argument of the sine function is the same as the expression on the bottom, and that happens here as well. Sine of 3x, the argument is 3x. The expression on the other half of the fraction is 3x. That's the same. So in that case, these are both equal to 1. So that's going to be 1 times 1. Now if we look at the term on the end, we have the limit as x approaches 0 of 5x over 3x. If we substitute there, we're going to get 5 times 0 over 3 times 0, which is indeterminate. Okay, so that's going to be indeterminate. But I think it's obvious that the x's here will cancel out. And so we're just getting the limit as x approaches 0 of 5 over 3. Now, we do know from last year, definitely, that the limit of a constant, 5 over 3, is just the constant itself. So the limit as x approaches anything of 5 over 3 is just going to be 5 over 3. It doesn't matter what x is approaching. So we have 1 times 5 over 3, so the limit is 5 over 3 is our answer. And again, if we look at the graph, it's an unusual graph, but again here, you have a hole, but the limit is 5 over 3. As x approaches 0, in other words, as you get closer and closer to the y-axis, the height of the graph is approaching 5 over 3. So we do have a hole, but the limit as x approaches 0 of f of x is 5 over 3. Just a little bit, 1 2/3, 2/3 of the way between 1 and 2. Okay, so again, an agreement with what we found down here. Okay, that should be everything you need to finish this set of exercises.